I live in a very humid climate, so I got a dehumidifier. This thing's really cool. It just constantly pulls water from the air and then puts it into this little bucket here on the back. The problem with the bucket is that every so often you have to come back and empty it, which is not fun and very lame. So we're gonna do something about that today. We're gonna make it a little bit more automatic.
The idea is pretty simple. We just need a way to detect when the bucket is full of water and a way to automatically remove said water. When the water reaches the top, it'll trigger a sensor that activates a pump which will run until the bucket is empty and then reset itself. That way, I can leave this running non-stop without worrying about it auto shutting off. The dehumidifier did come with a hose that you can use to bypass the bucket entirely, but the issue is that it works off gravity, so if you have your dehumidifier on the floor and want to pipe your water into a sink or bathtub, you're out of luck.
My first idea for the pump was to just put a tube on the input and then just have the output spray directly into wherever we're draining this into. So I have my test set up here, and then here's what happened when I actually plugged it in and activated it. So they didn't actually do anything, and the reason for that is that this is not a self-priming pump. This is what's known as a centrifugal pump, meaning there is an impeller inside here with a bunch of paddles on it, and as it spins around, it will fling the water out the outtake pipe. The problem is that there's no water in here, and therefore it was just spinning around flinging air. So it made a little bit of a suction, but not enough to actually get the water going. If you notice, the water crept up the pipe just a little bit, but not enough to actually get into the pump here and start going. I did a test earlier where I put the pump way down low, and then that actually had enough suction to get over the hump and start going. But this one did not do that. I do have a new design I want to try out that I think is going to work a lot better for the final product.
So apparently I didn't actually record footage of this, but what I ended up doing is instead of putting the tube on the intake pipe, I put the tube on the outtake pipe and just submerged the pump completely in the water, meaning priming the pump is no longer a problem since water is no trouble getting into the mechanism in the first place.
Alright, so this is the test to see how long it takes to actually empty this. We don't need it to empty all the way, we just need to empty most of the way. So I have the full tank here, this is fresh off the dehumidifier, and let's get this going and see how long it takes to empty it completely. That was about 27 seconds or so. I'll count it for sure when I really edit the video, and I'll put that on the screen if I can, but that's good because that didn't take too long, and there's really no hurry. Again, remember, we don't need to empty this completely, we just need to empty it enough to where we keep it from triggering that. So now that we have the mechanism to remove the water from the bucket, now we need to make the mechanism to determine when the water level is high enough to actually remove from the bucket in the first place. And we're going to use this guy. This is the water level sensor that I talked about in the previous video. This should make it nice and easy to remove it from the bucket.
To actually assemble these electronics, I took this mini breadboard and slapped an LED and current limiting resistor onto it. This will give me an indicator when the sensor detects water. This will also be removed later and replaced with the pump in the final design. The resistor value isn't too important, I just tried a few until I was happy with the LED brightness. For the rest of the electronics, you're going to need our indicator, the water level sensor, a relay, a microcontroller, and some miscellaneous wires I had lying around. For the microcontroller, I'm using an Arduino Mega 2560. We'll plug the negative side of our LED circuit into ground on our microcontroller and the positive side into the common terminal on the relay. This relay has both a normally open side and a normally closed side, but we're only going to be using the normally open side this time, connecting it to what will be our positive power supply. This positive supply will also connect to the DC plus terminal on the relay input. Of course, in order to get power to everything, we need to connect the supply rail itself to the 5-volt port on the Arduino. The DC minus terminal on the relay connects to the rest of our grounds. Next up is the input terminal on our relay. The signal going into this is going to determine whether or not the relay activates. We'll connect that to our digital input pin too. For the water level sensor, the minus terminal goes to ground, the plus terminal goes to our positive power supply rail, and the S terminal goes to the analog input pin A0.
So as you can see, I cleaned up the circuit and I put it on this very professional looking panel board that I had custom ordered, and I used engineering tape to secure everything so it should be nice and sturdy. And as you can see, I extended the wires that I'm using for the water level sensor, and what we're going to do is we're actually going to connect the bucket to the dehumidifier how I want it to be during operation, so I don't have to keep taking it off, because what's the point if I have to, and we're going to see if this works. So here's a video of the entire system hooked up. I've got my little panel board here, and so I have this water level sensor which is connected to the microcontroller, which is going to detect when this dehumidifier fills up the bucket. It's going to signal this relay, which is powered by this 12-volt power supply, which is going to power this pump, to suck the water in and expel it out into, right now I just have a clear dish to show you. You can pump it anywhere. You can pump it into a bucket, into a sink, into a bathtub, into a coffee maker. I'm not gonna judge you, just wherever. And you don't have to worry about gravity powers or the length of the hose that's built in or anything like that. So really convenient and it works great.